Today's lab is going to be there's going to be three parts. First part is we're going to try to figure out the heat capacity of aluminum, and on a PowerPoint I'll talk about heat capacity. It's an important quality, especially when we look at life on Earth. Okay, so I'm going to go through the different steps, and again, what I'll do is I'm going to go through the experiment and do the experiment. You need to make sure you record the results. There will be a quiz about it, and then there will be some work you have to do in terms of problems to figure out the heat capacity of aluminum. All right, so first thing I'm going to do is I'm going to measure out some water and weigh. I'm going to weigh out some water. So I have my scale. Okay, and let's zoom in. And what I'm going to do is I'll put them in a styrofoam cup, and we'll see why in a minute. So I want to zero the styrofoam cup and weigh the water. Okay, so I got some water here in a Erlenmeyer flask. It's just tap water, doesn't matter. And so make sure you record this. So it looks like it's 117.15 grams. Okay, so I'm going to set it aside, set it over here, and set it right next to the right there. Okay. Anyways, so I'll show you where I set it up in a minute. The next thing I need to do is I'm going to weigh out some aluminum. Okay, so I have a test tube here with a clamp. I'm going to show you what I'm going to do with that in a minute, and I'm going to add to about here on the test tube. Okay, hopefully you see that. So I'm just going to first zero it. Okay, and then I'm going to start adding some aluminum. Okay, so I added that much. Okay, and I'm going to set it down. And it says I measured out 12.00 grams. So write that down. Okay. All right, so next thing is what we're going to do with it. Okay. So I have my water here. And that's going to be, I'm going to set that right here. And I'm going to put the aluminum, and you'll be able to see it in a minute. Okay. Now I need to add a little bit more water to the flask on top. That's not the water I put in the cup, but you'll see what we're doing in a minute. All right, so okay. So hopefully you see what I did there. Okay, so I have aluminum that's in some water in a beaker. I have a thermometer, and then I have some other water here that in my cup. And I'm going to set a thermometer into it and proceed with the experiment. So, hopefully you see everything. Okay, so I need to take the initial temperatures of both the water and the water inside the beaker. So what's going to happen here is I'm going to heat the beaker, the water beaker, and as it heats, it's going to transfer its heat to the aluminum, and the aluminum's temperature is going to increase. just like the water is. In fact, the aluminum's temperature will be the same as the water's temperature. So I can measure the temperature of the aluminum by measuring the temperature of the water. I'm going to let the temperature of the aluminum go up to pretty close to boiling. And then what I'm going to do is I'm going to remove the aluminum, and then I'm going to put it inside the cup, the water. And then what should happen is that the warm aluminum will start to heat up the water inside the cup, and the temperature of the water will go up. So what's happening is there's a transfer of energy from the aluminum heat to the water heat. And we'll go through the actual formal discussion of that, and through that we'll discover what is called the heat capacity of aluminum. Okay, all substances have heat capacity, and we'll discuss that PowerPoint. So the water temperature in the cup is 20.0, and so is the thermometer inside the heating beaker. So I'm going to start heating that up. So again, the way to go through the Bunsen burner, getting it going, and this is going to take a little while as far as the heating goes. So my guess is you probably want to just fast forward it, but I'm going to keep it going while it's going heating up. But so the way that I do it, I make sure that the Bunsen burner is turned off, and that's, you turn it all the way to the right. Make sure there's air coming in. Okay, don't have this twisted all the way down, because air and gas need to be present for this reaction to take place. Okay, I turn it off, but I turn it on at the valve. Okay, and then what I can do is manipulate the amount of gas by I think I can. So some reason it's either the beaker, the Bunsen burner, or the valve, and I'm gonna suspect that it's the Bunsen burner, and give another Bunsen burner. Okay. Now I know this Bunsen burner works because I used it a little earlier today. So it's a little bit different. So turn it off. Okay, turn it on. And this time, if it doesn't work, then I'll have to move the valve. Okay, so I'm going to let that heat up, and I don't know how long it's going to take, but just be patient with it. I'm going to raise it up a little bit. Find something to put it on. I like the flame to only be about a couple inches under the thing I'm heating. Now I just leave it the way it is. Okay. There's a little problem with this Bunsen burner. It's got a leak. So, I'm gonna start over and smell gas. And there's a leak at the valve. So the gas that comes out is natural gas. It's methane, and it has it's odorless gas. And so what we do is we add a chemical to it. So if there's a leak, you can smell it. Okay. So let's try it again. So I know that this Bunsen burner works because I used it earlier today again. Okay, I'm gonna turn off at the turn on here at the valve, strike the match. Okay. All right, now we let it go. Again, I'm gonna let it go up to about, ideally like to let it go up to boiling, and hopefully it won't take that long, because that way we can get pretty much an exact number to this. Okay, so right now we're at 12 minutes and 16 into the video. And it goes up fairly quick right now. It's at 34. Okay. Let me tell you about the next experiment while this one's heating up. Is the next experiment. Okay, so you can see it heating up. You can see the bubbles. Next experiment, what we're going to do is we're going to take some ice and put it in some room temperature water. And what's going to happen is the ice is going to melt. And the reason why it's melt is because the room temperatures, the heat in the room temperature of the room temperature water is going to transfer to the ice, and it's going to melt it. And what we're going to do is we're going to find out how much energy it takes to melt a certain quantity, ideally a mole or a gram of water. Okay, so it's up to 439 degrees Celsius, and that's it's about body temperature right there. Okay. So it's gone up 20 degrees fairly quickly. So what I want to do is when it gets to boiling, I'm going to take it and then I'm going to put it inside this two styrofoam cups. And the reason why we have the styrofoam cups here, these guys are insulated. So what we're going to say is that the heat from the aluminum pellets is to only heat the water and not the surroundings. Okay, so in Chem 121, you cover this and you talk about systems and surroundings when you talk about enthalpy. And if you haven't had 121, then just know that what we're doing is we're heating up. What we're trying to do is keep all the heat that's going to come from those pellets. We want it to stay inside the water And these cups, styrofoam cups, are good thermal insulators. That's why we use them, you know, like for keeping our cold drinks and our hot drinks, like coffee or whatever drink, cocoa or whatever you drink. To and you want to keep the temperature constant. So it's at 54 degrees now. So far we have the mass of the water, the mass of the aluminum, the initial temperature of the water inside a styrofoam cup, and we took the initial temperature of the thermometer, though we didn't need it, but it is kind of important because we're using two different thermometers. If the initial temperatures were different, then the initial temperatures would have to be incorporated in with our calculations. But it usually turns out that all thermometers that we use give us the exact same temperature in our environment. And it's not because the environment's changed, it's just because the thermometers have different often measured, may not be calibrated quite right, or have lost their calibration. So it turns out these two guys start out with the initial temperature, so we don't really need to know the initial temperature of the aluminum. Okay, but we got it, but we don't need it. What we really need is the temperature that we're going to stop the heating. Okay. So far we have the mass of the aluminum pellet, the mass of the water inside the cups, and the temperature of the temperature in the cup. Okay. Then the next value we're going to measure is when I take off the aluminum, we're going to record the temperature that I take it out, and then when I dump it in the water, we're going to let the heat go up, and it's going to stop at a certain point. At whatever temperature stops going up, that's the temperature that we're going to record. So there's going to be two more temperatures that we're going to record. There's going to be the temperature of the aluminum when it's heated, and we're going to talk about what that means when we go over the calculations. And then the temperature of the water after it's been heated in the cup. Hopefully you got that. Okay. All right, so it's up to 69 degrees. Just like other videos, there'll be a quiz basically on what I'm doing right now, you know, the things I'm talking about right now, and you know, results, and then there's going to be a worksheet where you're going to have to, then there'll be a PowerPoint to show you the work that I want you to show, the actual math and the formal presentation of this. Also, the important thing about this, and I am going to show this, so I have this video for two classes, 110 and 121. For the 110 class, it's important for you guys to notice that, learn about heat, even though we don't talk about it in the lecture, okay, how it relates to chemical reactions. For 121, when we talk about enthalpy, this is the actual, you will be incorporating this into the lecture. There will be a section on enthalpy, maybe coming up soon, like it is right now, or whenever it is according to the class schedule. Okay, so right now the temperature is 78 or so, and so again, the thermometer measures to the 1, so we have to do is record, remember our guess digit, so it's not going to be like 78, it's going to be like 78.1, or wait, this memory go to the tenths. You can always go to one more digit than you can read on a scale. Okay, so when the water boils, that's when the temperature stops going up, and we'll talk, and that'll be discussed as well, is that the heat is going in to change, not the temperature, but it's going in and change the state. That's what happens to boil. Right now, the heat is going into the water and changing the temperature, but when you get to the boiling point, the heat doesn't change the temperature anymore. What it does is change the liquid to a gas. It's similarly with freezing and melting. When you melt ice, okay, or when you freeze water, okay, the temperature comes down to 32 degrees Fahrenheit, and so you cool it down to 32 degrees, and when it gets to 30, and the water temperature goes down to 32, but when it gets down to 32, it's going to stay 32 degrees until all the ice turns solid. Until water all turns solid into ice. At that point, if you start taking away heat, the temperature of the ice actually goes down. A lot of people don't realize that ice can be colder than 32 degrees. Just like you have cold water and hot water, you can have cold ice and hot ice. So you can have hot ice, cold ice, hot liquid water, cold liquid water. You can have hot water vapor, gas, or you can have cool water vapor, but it's still a gas. So, right, we're getting there. So it's 90, almost 90 degrees. So theoretically, if this is, if this actually were perfect conditions, it would get to 100 degrees, and that's when boiling would be. There's variables in the thermometer, also in the environment, that makes those types of conditions not exactly 100 and so degrees Celsius. By the way, just to let you know, it's about 2 Fahrenheit degrees per 1 Celsius. So if we go up, right now it's gone up 1 degree Celsius, it's gone from 91 to 92. That's essentially going up 2 Fahrenheit degrees. Okay, so when the thermometer stops going up, that's when I'll do the transfer, and it'll happen in a minute. I have to be careful when I do this because everything's going to be hot, and I'm going to not want to lose heat and try to keep. So I got some paper towelings so when it gets up to my boiling point, I'm going to turn off the heat, turn it off at the valve, okay, undo the clamp, and then I'm going to pour, and then I'll hold the test tube, wipe it a little bit, and then pour it into the cup, and then cover it, and then swirl it until the temperature stops going up. Okay. Okay, now it looks like, so boiling isn't when the water starts to bubble. boiling is when the atmospheric pressure and the pressure that's pushing down, the air pressure, is equal to the pressure that the gas that's pushing up. And in Chem 122, we talk about that more in depth. Okay. All right, it's at 98 degrees. So when it gets to the point where I'm gonna take this out, I'll give you the temperature of the thermometer, and then we're gonna pour it into here. And the temperature of the cup is 20.0. Okay, you can tell it's, you know, we're close to boiling because it is bubbling, and it is a property of boiling as you get the bubbling. And that's because the air inside the water is being released. So the heat won't go up any further. It's going to be just going to stay at the boiling point. Water can't get in. Liquid water can't get any higher than this boiling point. And this is 101. That's because the thermometer must be off. Okay. Okay, I'm fairly satisfied that it's ready to go. So what I'm gonna do is I'm gonna turn off the gas and move the aluminum to the cup. So the temperature is 101.5. Okay. So this is hot. And it's not coming out. Come on. Okay, there. Not the most smoothest transition, but we got to go with it. Okay, so the temperature is going up. So I'm going to swirl it around. That's to distribute the heat of the aluminum. Okay. And there's a point where it's going to go up, and then finally stop going up, and then eventually slow down. So it didn't go up a lot. We'll say 22.5. Okay, so stir around just a little longer. Changes. Oh, 22.5. Okay, so that's it. So that's it, and so that's final. So we got 101.5 is our heat of aluminum before we put it in. We have 22.5 of the aluminum and the water. We have the mass of the aluminum, we have the mass of the water, and we have the very starting temperature of 20.0. Okay, so that's it for this lab, and there'll be a PowerPoint on what to do with this.